Black holes are the largest things in the universe. Unlike planets or stars, they have no physical size limit. They can grow endlessly. But not all black holes are the same. Some are gentle giants, others are universe-eating monsters. So how do they grow? And how large can they actually get? Let's start small. Primordial black holes. The smallest kind may or may not exist. If they do, they formed just after the Big Bang, when tiny pockets of dense energy collapsed. The smallest one that could still be around would have the mass of a large mountain, but be no bigger than a proton. A primordial black hole with the mass of Earth would be barely larger than a coin. We haven't seen any yet, but they're a candidate for dark matter. Stellar black holes. To make a black hole today, you need a supernova or a neutron star merger. Let's use the mass of our Sun as our unit. The smallest known black hole has about 2.7 solar masses. That's a sphere around 16 kilometers wide, large enough to cover Paris. One of the largest stellar black holes is M33X7. It's eating a blue giant, shining 500,000 times brighter than our Sun. Yet it's only 15.6 solar masses and 92 kilometers wide, just big enough to cast a shadow on Corsica. To grow much larger, black holes need to merge. Recently, two black holes in a galaxy 17 billion light-years away spiraled together, releasing more energy in gravitational waves than all the stars in the Milky Way emit in 4,400 years. The new black hole they formed is about the size of Germany and has 142 solar masses. And here we hit a gap. Lots of black holes up to 150 solar masses. Then nothing. Until suddenly we find black holes millions of times more massive. The universe isn't old enough for them to have grown just by eating stars. Something else must have happened. Quasi-stars, the missing link. Enter quasi-stars, the largest stars that ever existed. The early universe was so dense that these stars could grow to thousands of times the Sun's mass. Their cores collapsed into black holes while the star was still alive. Gravity fed the black hole, while the heat from infalling material kept the star stable. These black holes consumed their host star for millions of years, growing to several thousand solar masses, wider than Earth. These became the seeds for supermassive black holes. Supermassive black holes. Now we arrive at the kings of our universe. Most galaxies contain a supermassive black hole. In the Milky Way, Sagittarius A Sagittarius has about 4 million solar masses, but is only 17 times the Sun's radius, smaller than many giant stars, yet millions of times more massive. But they are not like the Sun in the solar system. They make up only 0.01% of their galaxy's mass. Dark matter holds galaxies together, not the black hole. Many are not gentle. The black hole in galaxy BL Lacertae produces jets of plasma at nearly the speed of light. If Earth orbited it, it would appear 115 times larger than our Sun in the sky, and we'd be instantly incinerated. The black hole in Cygnus A has 2.5 billion solar masses and is 14.7 billion kilometers wide. If it replaced our Sun, it would swallow all planets and stretch halfway to the edge of the solar system. M87's black hole, 6.5 billion solar masses, was the first we ever photographed. Its shadow covers our entire solar system. Ultramassive black holes. Now we reach the most massive black holes, perhaps the largest single bodies that will ever exist. They've grown to tens of billions of solar masses. Their accretion disks shine brighter than thousands of galaxies. We call them ultramassive black holes. OJ287 has 18 billion solar masses. It's so big that another supermassive black hole, 40 times larger than Sagittarius A, orbits it. It can fit 3 solar systems side by side. The King of Kings, TON 618. And finally, the monster. TON 618 shines with the brightness of 100 trillion stars, visible from 18 billion light-years away. It has 66 billion solar masses. It would take light a full week to reach the singularity after crossing the event horizon. About 11 solar systems could sit inside it side by side. It may be the largest single body in the universe, and because it's so far away, we're seeing it as it was 10 billion years ago. It's probably even larger now. From a proton-sized primordial black hole to something that swallows solar systems whole, black holes are the universe's ultimate story of growth. Gentle giants, universe-eating monsters. They will be here after everything else dies, growing larger and larger.